Hello everyone, welcome back to ChemOrgChem. So if you have been following along, you know we recently discussed into Sonogashira cross-coupling reaction, its mechanism and application and their details. So now it's a time to put that knowledge to the test. So here today we are going to tackle a solution for 10 practice problems. So those are designed to solidify our understanding of this powerful carbon-carbon bond forming reaction. So whether you are student or a researcher or just a chemistry lover, so these problems will challenge you and help you master the Sonogashira cross-coupling reaction. So let's moving in. What is Sonogashira cross-coupling reaction? So let's see briefly. So this reaction is palladium and copper co-catalyst reaction between organohalide or organotriflate with terminal alkyne which produce this corresponding carbon-carbon coupling product is known as Sonogashira cross-coupling reaction. So let's see one by one all the problems. So this is our problem number 1. So here we are asked to predict the product of the following reaction. First, let's identify the key components in this reaction. So here you see one terminal alkyne is present in the substrate. So in case of here you see here one chloride substituted substrate also present. So now you see here palladium catalysis as well as copper co-catalysis are given and N-butyl amine also given for this reaction. Remember the Sonogashira cross-coupling reaction essentially replaces the chloride on the substrate with this terminal alkyne. So let's see the product structure. So here you see cross coupling takes place this position and with this position. So resulting that produce this corresponding product. So here so note it down the stereochemistry of alkene geometry is not disturbed under this reaction. So let's moving on our second practice problem. So here we are asked about to predict the correct product formation for this reaction. So particularly you should look this substrate. So this substrate bromide substituted aryl system and also some boron species also substituted in this aryl system. So here alkyne is present as well as here palladium catalysis and copper co-catalysis also given with triphenyl phosphine as a ligand and diethylamine also present. So under this reaction condition, so here this position coupled with this terminal alkyne, so resulting that produce this corresponding product. So here you should note it down this boron substrate. So here you should note it down this boronated species doesn't affect in this reaction. Let's moving on our third practice problem. So here you see this substrate react with 3 times under Sonogashira cross-coupling reaction condition. So here they used ionic liquid as a solvent for this reaction. So initially two equivalent of the same substrate react together which forms this corresponding intermediate. So this intermediate react with the same substrate again that produce this corresponding cyclic product. So now let's moving on. So this is interesting practice problem. So now you see, so this thiophene substrate has two bromide substituent. So this substrate react with this terminal alkyne under Sonogashira cross-coupling reaction condition. So here there are two sites are there in this thiophene system. You just remember that in Sonogashira cross-coupling reaction, the more electrophilic site that readily undergo coupling with terminal alkyne. So as per that, so here this position is more electrophilic position. Therefore, initially Sonogashira cross-coupling takes place this position to produce this corresponding intermediate. The same reaction mixture if we add one more alkyne so that readily coupled with this position to produce this corresponding carbon-carbon coupling product. So let's moving on our fifth practice problem. So this problem somewhat related to regioselectivity in Sonogashira cross-coupling reaction. So here in this substrate has two bromide substituent as well as one iodide substituent. However, we know that iodide is more reactive when compared to the bromide. So therefore, this position readily coupled with this terminal alkyne under Sonogashira cross-coupling reaction condition, which produce this corresponding carbon-carbon coupling product. So let's moving on our sixth practice problem. So this problem also based on regioselectivity in Sonogashira cross-coupling reaction. So now you see this substrate has two bromide substituent. So let's think about which position has more electrophilic nature. So based on that, this position is more electrophilic nature because of here carbonyl also present. So therefore, here coupling takes place, especially this position, coupling takes place with this terminal alkyne to produce this corresponding product. So let's moving on our seventh practice problem. So here we asked to find out the correct product formation for this reaction. So now you see, so here bromide substituted substrate present as well as one terminal alkyne also present. So now under this Sonogashira cross-coupling reaction condition, so here this side coupling going to takes place with this terminal alkyne that produce this corresponding carbon-carbon coupling product. So here you should note it down the stereochemistry of these two alkene geometry doesn't alter under this reaction condition. So now let's moving on our eighth problem. So here you see this problem. So this problem also related to regioselectivity in Sonogashira cross-coupling reaction. So now you see this thiophene substrate has four bromide substituent. So this substrate react with two equivalent of terminal alkyne under this Sonogashira cross-coupling reaction condition. So just to remember that, so first we should see which position is more electrophilic position. So in general, in thiophene, so this second position as well as fifth position has more electrophilic nature. Therefore, Sonogashira cross coupling takes place second position as well as fifth position to produce this corresponding product. Let's moving on our ninth problem. So here we asked to find out the starting material for this reaction as well as intermediate for this reaction. So here they give an final product for this Sonogashira cross-coupling reaction. So let's solve this reaction by backwards. So here they given tetrabutyl ammonium fluoride. So for in general, tetrabutyl ammonium fluoride is useful for deproduction of terminal alkyne, especially silyl deproduction of terminal alkyne. So as per this problem, so here definitely should be some silyl group must be present. Therefore, this is maybe the correct intermediate for this reaction, which is trimethyl silyl group. So when we use tetrabutyl ammonium fluoride, which quickly deproduct the silyl group that produce this corresponding terminal alkyne. So now you see this bromide substituent react with some terminal alkyne under this reaction condition which produce this corresponding intermediate. Now you disconnect this bond, especially this bond. So resulting that you get this corresponding alkyne. So this is the our exactly correct alkyne for this corresponding reaction. So let's moving on our 10th practice problem. Here we are asked to predict the intermediate for this reaction as well as the final product for this reaction. So let's see first reaction condition. So this substrate react with methyl iodide and potassium carbonate. So when we use potassium carbonate, which readily takes this NH proton, So resulting that N negative charge readily attack with this methyl iodide by SN2 reaction, which produce this corresponding methylated product. So now you see this product contains one bromide substance. So this substrate readily undergo with Sonogashira cross-coupling reaction with this terminal alkyne. So resulting that carbon-carbon coupling takes place with this position as well as this terminal alkyne position, resulting that produce this corresponding product. So now let's moving on our 11th practice problem. So here we are asked to find out the intermediate as well as terminal alkyne for this reaction. So here they given final product for the Sonogashira cross-coupling reaction. So first let's solve one by one. So now you closely look this ketone substrate. So this ketone substrate initially react with KHMDS base. So when we use base, so this is the active position. So resulting that one of the proton readily removed by this base. So resulting that produce corresponding enolate ion. So this enolate ion react with Cummins reagent. So this is the structure for Cummins reagent. So this is mostly useful for preparation of organotriflate compounds. So therefore, when we use Cummins reagent that readily produce this corresponding organotriflate, so now you should see this final compound structure. So now you break this carbon-carbon bond, so resulting that produce this corresponding alkyne substrate. So now you see this organotriflate react with this terminal alkyne, so resulting that produce this corresponding product. So let's moving on our 12th practice problem. So problem 12 present a slightly more complex scenario. So here we have a Sonogashira cross-coupling reaction condition along with terminal alkyne. So here they treated with some tetrabutyl ammonium fluoride that produce this terminal alkyne. So this terminal alkyne undergo by Sonogashira cross-coupling reaction with this bromide substance that produce some product. So that product undergo by palladium charcoal hydrogenation, which produce this final product. So let's solve one by one. So first to take this intermediate. So this intermediate obtained by the treatment of tetrabutyl ammonium fluoride, which indicate that here there is some silyl protecting group. So at the same time, so here you should come. So here you see they given some terminal alkyne. So which is tips which is tips protected alkyne. So this terminal alkyne involved in the Sonogashira cross-coupling reaction. So therefore must be this intermediate structure should be like this. So now you see, so this terminal alkyne has tips group here. So now you disconnect this carbon-carbon bond. So resulting that produce this corresponding terminal alkyne. So here should be either bromide substance or iodide substance present in this substrate. So resulting that this may be the correct answer for this box. So now you see here either bromide or iodide substituted substrate which react with this terminal alkyne under Sonogashira cross-coupling reaction condition, which produce this corresponding product when we use tetrabutyl ammonium fluoride that produce this terminal alkyne. Now this terminal alkyne react with this substrate. So here you see, so this position going to couple with this terminal alkyne under the Sonogashira cross-coupling reaction condition. So which produce this corresponding product. So in next step, this substrate react with palladium charcoal in the presence of hydrogen gas. So here we should see which functional group is more reactive towards palladium charcoal hydrogenation. So exactly here alkyne is more reactive. Therefore, when we use palladium charcoal and hydrogenation condition, so which readily reduced that produce this corresponding product. So that's it. So solution to 12 practice problems on the Sonogashira cross-coupling. I hope this video has helped you to solidify your understanding of this essential reaction. So remember to practice regularly and don't hesitate to revisit the mechanism if you are struggling. If you found this video helpful, please give it a thumbs up and subscribe for more chemistry content. Let me know in the comments if you have any questions or suggestions for the future videos. And finally, thanks for watching. Bye bye.